Hi everyone, welcome to Edu-Malanga. Thank you for joining us today. Today we're doing the last video on the third unit of the year. In this video we're going to look at logarithmic functions, and we're going to look at the relationship between logarithmic and exponential functions. Let's get started. To understand the relationship between two functions when one is logarithmic and the other one is exponential, let's start by remembering the relationship between the formula of an exponential function and that of a logarithmic function. If we remember, an exponential function looks like this. You have y is equal to a, which is your base, to the power of x. And if you were to derive a logarithmic function that would correspond to this exponential function, the logarithmic function would look like this. You would have log base a. So what would happen is that your base would remain the same. Your base is a in the log as well as in the exponential function of y. So the final answer is what is the input when you are doing your log function is equal to x. And what do you solve for? You solve for the exponent or the power in your log function. So that is the relationship between exponential and logarithmic functions when you're looking at the formula. But what does it mean for us when we are creating graphs of these formula? The best way to understand the relationship between the graphs of an exponential function and that of a logarithmic function will be if we draw the graphs ourselves. And what we're going to do is we're going to draw the graph of log base 3 of x, and this we're going to call our f of x. We'll draw this graph on a Cartesian axis, and then on the same axis we'll draw the graph of 3 to the power of x, and we're going to compare the relationship between these two functions. Let's get started with the graph of f of x, and we're going to define our range and our domain values again. The values in our range, which is the values of x, are going to be, remember when you have a log function, your domain values must always be greater than 0. So we're going to start with 0.1. We're then going to have 1 over 3, then 0.5 and 1, then 2, 3, 4. Let's skip 5. We're going to do 6, and we're going to skip 7. We're going to do 8, and then the last value we will do will be 9. I know I've skipped 5 and 7, but I've done that strategically. Essentially what I'm trying to do is to use the values that I know have a relationship with 3, because our base is 3 and 6 has a relationship with 3 as well as 9. So I want to use those in my graph so that I can spot any very obvious relationships that are there to see. Let's solve for the values of our range now. These will be the output values, which will be f of x. I've pre-calculated these values, so I'm just going to fill them in. I do suggest that you pause the video and calculate them yourself. This will help you to practice for your tests and your exams. Let me fill them in. And so these are the values of our domain and our range for the function f of x is equal to log base 3 of x. Now I'm going to draw this function on this Cartesian axis. So let's get going. We'll start with the x-intercept, and that is the value 1, 0. So when x is 1, y is equal to 0, and that is a point on our function. We're going to move to the decimal points. When x is 0.5, y is minus 0.63. And when x is 1 over 3, y is minus 1. Okay, let's start with 0.5. When x is 0.5, y is minus 0.63. I'm going to make an estimate somewhere perhaps over here. And when x is 1 over 3, y is negative 1. So somewhere about there. Let's do the last decimal point. When x is 0.1, y is negative 2.10. So when x is 0.1, y is negative 2.10. So somewhere about there. Let's plot the whole numbers now. When x is 2, y is 0.63, and when x is 3, y is equal to 1. So when x is 2, y is 0.63, so somewhere about there. And when x is 3, y is equal to 1. Let's continue. When x is 4, y is equal to 1.26, and when x is 6, y is equal to 1.63. So when x is 4, y is equal to 1.26, so somewhere about there. And when x was 6, y was equal to 1.63, which is somewhere about here. The next value we did was when x is 8, y is equal to 1.89, and when x is 9, y is equal to 2. When x is 8, y is equal to 1.89. We're going to have to stop here, unfortunately, because our Cartesian axis stops at 8, but we can draw this function, and let's do that. The function looks like this. And this is the graph of f of x is equal to log base 3 of x. And so we've drawn our logarithmic function. Let's move on now, and on the same Cartesian axis, we're going to draw the function g of x, which is equal to 3 to the power of x. We'll again start by determining the values of our range and our domain. What is the function? G of x is equal to 3 to the power of x. Let's start by defining the values of our domain, our x values. For this function, we're going to start with -3, -2, -1, 0, 1, 2, and 3. Because it's an exponential function, we don't have all the restrictions that we had with the log function. So here, we may choose values of our domain that are negative. Now let's calculate the values of the range that correspond to each of the values of the domain. I'm again going to just fill these in, but I do recommend that you solve them yourself. Let's plot these values on the Cartesian axis as well then. We're again going to start with now our y-intercept, and that is where x is 0, y is equal to 1. So let's plot it. When x is 0, y is equal to 1. This is the point. Let's continue. We're going to go to the negative values. When x is -1, y is 1 over 3. And when x is -2, y is 0.11. Let's draw this. When x is -1, y is 1 over 3. So it's a third, somewhere perhaps about there. And when x is -2, y is 0.11. So a very small number somewhere there. The last negative value we will plot is when x is -3, y is 0.04. When x is -3, y is 0.04, which is very small and close to the x-axis. Let's move to the positive values now. When x is 1, y is 3, and when x is 2, y is 9. Let's draw that. When x is 1, y is equal to 3, and when x is 2, y is equal to 9. This will again be the last value we can plot, and this is the graph of g of x is equal to 3 to the power of x. So there's something interesting when we look at these graphs. What relationship do we believe that they may have? Let's start by maybe comparing some common values that occur in these graphs. In the graph of f of x, we had an x-intercept, which was this point over here that I'm highlighting. And so when our x was 1, our y was 0. And in the graph of g of x, we had a y-intercept, which I'm highlighting over here. Okay, and so when our x was 0, our y was 1. It looks like we're swapping the values of x and y between the graphs. 1, 0, 0, 1. Let's use another set of points to check this. we're going to use the values 2 and 9 over here. When x is 2 for g of x, your y is 9. Let's check what happens with f of x. With f of x, when x is 9, your y is 2. Yes, we are swapping the values of x and y. If you recall, in lesson 2, we looked at functions and inverse functions, and the way that we find the inverse of a function is by swapping the x and the y values. So for example, for the function f of x is equal to log base 3 of x, to find the inverse of the function, we would have to swap the x and the y values, and so it would become x is equal to log base 3 of f of x. By swapping the x and the y values and then drawing the function, we create the inverse of that function. There was also a second way we learned to prove that a function is an inverse of another, and that was by checking that the functions are reflected about the line y is equal to x. So let's draw that line on this axis. For the function y is equal to x, 1 will go to 1, and 2 will go to 2, 3 will go to 3, 4 will go to 4. This will be the same for the negatives. Negative 1 will correspond with negative 1, negative 2 with negative 2, negative 3 with negative 3, and it will keep going, but let's draw what we have over here. This is the line y is equal to x, and when we look at these graphs, we can see that they are both a reflection of each other about the line y is equal to x. So what can we say? We can say that g of x is the inverse function of f of x. Let's write that down to make sure you understood it before we end the lesson. When you have a logarithmic function, log base a of x, and your function is f of x, and you make an exponential function with these, which will be g of x, and that will have the same base, so our base will be a to the power of x. The relationship between these functions is that they have an inverse relationship. So they are the inverse of each other. And this is the relationship between log functions and exponential functions. I hope you understood it and that I explained everything clearly. If you have any questions, please leave them for me in the comments section. This was the last video on Unit 3. We're going to move on and start doing the 4th unit of the year, which looks at finance.